3.4. We're gonna talk about writing equations of lines. So this time, in this lesson, they're going to give us a graph. We don't have to graph stuff. We just have to create a equation off of the graph. What'd you say, Ellen? I'm perfectly fine with that. You're perfectly fine without graphing and just coming up with an equation?
Yes.
Okay, so we've graphed a couple ways. What are the two ways that we've graphed so far, really? Or three, I guess. Like plugging in points. Okay, good. What else? Slope, intercept form, and what was the other way last night? No, what we just talked about with Caden's last problem he asked. What would that be called? What did we do there? When you plug zeros in for x and y and solve, what are you actually essentially finding? The intercepts, okay? So if we have any of those little pieces of information, we can create equations off of it, okay? So if you are given a slope and an intercept, you put it in slope-intercept form, y equals mx plus b, okay? We did some of this last year in geometry too, I do know that. If you are giving a slope and a point, you have to use point-slope form and solve for y so that you can create your equation in y equals mx plus b form, okay? And then the other part is if you are given 2 points, okay, an x1, a y1, an x2, a y2, you use the slope formula to find the slope, then you can use point-slope formula to create an equation. Okay, that's like a two-stepper. You have to find the slope first, then use one of the 2 points to find point-slope form, and then it will move it into there, which makes life nice, okay? So there are 3 ways that I can create equations of lines. I'll give you a second, because I'll start writing. Okay. So, with that being said, we're going to look at equation, or look at graphs and write an equation. Okay, this graph, what information do we have on this graph? Slope and y-intercept, so what form am I gonna use? So I'm gonna use slope-intercept form, y equals mx plus b. What is my b? -2. What is my slope? I went up and over, so my slope is 3/4, and you put an x, and bam, I've got my equation.
Yes, we don't talk about this.
Those are the easiest ones, I don't have any math to it. If I have an intercept and I have a slope, I can literally create my equation just by looking at the picture. Pretty simple, okay? We can count the spaces up and the spaces over to the next point. And always pick like a definite point, don't pick a point like this, that's impossible to figure out, okay? Be smart, pick a point that's like on something. Okay. Write an equation of the line that passes through 5, 4, and has a slope of -3. What information do I have here? Oh, is that a y-intercept? Nope, it's just a point and a slope. So I'm going to have to use point-slope form. Point-slope form. Okay? Point-slope formula, what does that look like?
Y minus y sub 1 equals m times
Y minus y sub 1 equals m times x minus x sub 1. Now, here's the trick to this. My m is my what? Slope. So my slope is -3. My x, or my x1 is what in this case? 5, good. And my y1 is what? 4. Okay? This y and this x are what's in the equation. Y equals mx plus b, okay? I don't put anything into there. I put stuff into that sub ones, the sub ones. So here I have y minus 4 equals my slope, x minus 5. Now, I'm not done with this equation because if I were done with it, it would be in this form. Y equals mx plus b. Okay, does that look like that form yet?
No.
No. So what do I need to do? Not yet, well, let's not do that yet, let's distribute first. Okay, so that when we add and subtract, it's just one step. So if I distribute this, I have y minus 4 equals negative 3x. And then what's negative 3 times negative 5? Now, L, let's move that 4 over. Does that make sense now?
Yes.
So add 4, and I get y equals negative 3x plus 19. Is that in y equals mx plus b form?
Yes.
Yes. Okay, so point slope form is not super hard. You can do that math. You can distribute, you can multiply, you can add, you can subtract. Okay, just make sure that you take it all the way through so that you get it into y equals mx plus b form. Any questions on that so far? How we feel about that? Okay? Okay. Let's move to another example. Okay, this time there's two portions to this, okay? It wants us to write an equation of the line that passes through negative 2, 3, and part A says it's parallel to that equation, or to that line that passes through that point. And the second part says that it's perpendicular to, okay? And it says the line y equals negative 4 x plus 1, okay? So we want to create an equation that is parallel to and an equation that is perpendicular to. Well, what do we know that's important about lines that are parallel to each other? They have the same slope. And what we know about lines that are perpendicular to each other? Opposite reciprocals. So I'm probably going to need to figure out slopes and stuff like that, okay? So they gave us enough information, we just have to think through stuff, okay? First of all, they gave us a point, right here. This is my point, yes?
Yes.
Okay, and then at the end, it says, to the line y equals negative 4x plus 1. What information do I need from that line? The slope. I'm going to pull the slope out of that, and then I'm going to use that point, and then I'm going to do two separate equations, one for parallel, one for perpendicular. Okay? So I need this slope of negative 4. So part A said that it wants a line that is parallel to, meaning the slope is the same, yes? Okay. So my slope on part A is going to be what then? Negative 4. And my point is negative 2, 3. So what formula do I need to use? Point slope form. And how do I set that up? How do I set point slope form up? Y. Okay, so what's my sub 1? What's y minus sub 1? What's my, okay, y minus 3 equals, and what goes here? Negative 4 times x minus what? Negative 2. Pause there for a second. Does anybody have questions on how I found that information? Or why I'm even using that information? We good with that?
So if they give you a line and point, you just take the slope from the line?
Mm-hmm. And use the point that they wanted to go through. Yep. Okay, now I do math. This is gonna stay y minus 3 right now. This is going to be negative 4x. And what is negative 4 times positive 2? And then I add 3, yes. And I get y equals negative 4x minus 5. This line is parallel to this line. And I know that also because they have the same slope. Now, I want one that is perpendicular to. So on the perpendicular to, what slope do I need to use? Positive 1/4. Okay, I need to change it right from the start. Positive 1/4, and my point again is negative 2, 3. How do I set that up? Y minus what? Equals what? 1/4 times x minus what? And I do math. This stays the same right now. What's 1/4 times x? 1/4 x. And what is 1/4 times 2? What? Yeah, 0.5, 1/2. Okay. I add 3. And you get y equals 1/4 x plus 3.5. And you can put it in decimal form, I don't care. It can be decimal or it can be fraction, as long as it's right, I can care less. Okay? Questions on either of those?
How did you go 1/4?
Because the slope of the line that it needs to be perpendicular to is -4. And if it's perpendicular to that line, it's the opposite reciprocal. So I have to flip it and make it the opposite sign. Does that make sense? Okay. Word problem. In the school year ending in 1993, 2 million females participated in U.S. high school sports. By 2003, the number had increased to 2.86 million. Write a linear equation that models female sports participation. How can female power? How can I figure that out? How can I figure that out? But yeah, we can do that. We can do years over something. How about if we flip it so that our years is our x-axis and our numbers are y? You know what I'm saying?
Yes.
Okay, so let's do that. Let's do 2.86, right? Minus 2.0 over our years of 2003 minus, was it 1993? Yeah. And that's gonna be our what in this case? What is that? When we take opposite, or when we subtract whatever over whatever.
So it's standard form?
We are gonna put it in standard form in a minute. It's what? Yeah, it's our slope. This is gonna be our slope. Okay? So I'm gonna I need to figure out a slope, and then I'm going to use one of the 2 points, and then I'm gonna put it in point slope form and then get it into standard form, into y equals mx plus b. Okay? So what is 2.86 minus 2.0? 0.86. Now, let me teach you a trick about some stuff that we could work with here. Okay? Let's talk about this for a second. What if we just changed, well, we know this. What's 03 and 93? What's the difference between those? 10. Okay. And then what does this change to slope-wise then? What's 0.86 over 10? What do you have to do with that decimal when you're dividing by 10? Yep. So I'm adding a 0. So it comes out to be 0.086 is my slope. Okay? Now, I use the slope that I have and I use a point that I have. What point do I have? What point would I have? I have a slope of 0.86, right?
Yes.
And do I have a starting point on this? Okay, 2 million in 1993 is my starting point. So what is my y of those two things? So what is my y-intercept? 2. In this case, it's literally 2. Because I can't go under that, right? Because they didn't give us data under. So my equation is done at this point. I say y equals 0.086 x plus 2.0. Because 2.0 is my, is my y-intercept, and 0.086. Now, when you plug numbers in and get an answer out, you know that it's going to be in millions, okay? But we don't need to write 2 million on there because that's crazy. It would take up way too much space when I graph. Yes? Okay, and then, so yeah, that's where we're going with that. Write a linear equation, that's our linear equation. Simple enough, don't overthink things. One more, okay? You have $30 to spend on downloading songs for your digital music player. This book is so old. Company A charges 79 cents per song. Company B charges 99 cents per song. Write an equation that models this situation. How could I do that? How can I write an equation that models that situation? What's the important information that we have?
79 cents per song.
Okay, 79 cents per song for company A, right?
Yes.
What else?
And 99 cents per song to company B.
99 cents per song for company B. What else do we have that's important? There's one other piece of information. Oh, good, we have $30 to spend. So what do you think, how should we try to set this up? How much total do we have to spend?
30.
Why don't we start there? 30 should probably equal something, right?
Yes.
Okay, so if I have $30 to spend on this, it should equal however many I do of one plus however many I do of the other, okay? So I can just give it variables. What's the cost for company A? 79 cents. Do you know how many you bought at company A? So let's represent that with a X. What's the price for company B? And do you know how many you bought at that company? So let's represent it with a, oh, look at that. A linear equation for it. Okay, a linear equation. I want to show you one other example and then I'll give you your homework, okay? I'm gonna write it up here. Let's say you are given 2 points, 5, -2, and 2, 10. And you need to write an equation, for those 2 points. How can I write an equation for those 2 points? It's kind of like what we did in our word problem, the first one. What do I need to write an equation? What are the 2 things I need? Slope and an intercept or a point, because I can do it with 2 different equations, yes? Okay, so let's start by finding the slope maybe. How could I find the slope of this? Okay, so 10 minus -2 over 2 minus 5, yeah? This gives me 12 and minus 3, which gives me what? -4. That's my slope, -4. Now, do I have a y-intercept? No, but what do I have, Eddie? You told me earlier. I have the slope and what else? A point. Does it matter which of those 2 points I choose? No, I can choose either because they're both on the line, so it doesn't matter which one, okay? So I'm just gonna choose this first one because it's there. So I have y minus -2 equals my -4 times x minus 5. Did we follow where all that came from? This becomes positive. 1 plus 2 equals, distribute, -4x. What's -4 times -5? Positive 20, subtract 2, and y equals -4x plus 18. That's your homework for tonight,
Yay.
okay? I'll give it to you. You are creating equations, which means we are doing just algebraic math, adding, subtracting, multiplying.